So spring will get elongated. So spring force will act here. Let this be the tension. T naught, I'll write it. All the initial things will write it T naught. And this is mg. The weight mg. And the buoyant force FB naught, I'll write it. Okay, this is the initial equilibrium. When I displace it, when I pull this block a little bit vertically down, the buoyant force will increase. Spring will get elongated further. So then therefore the additional spring forces will be acting. If you want, I'll go for one. I think not needed. So when I displace it further, so initially some say like a h length, h naught length was immersed here. Then if you further press it, plus x, let it be. So x length of the slab or the block inside the liquid will increase. So the buoyant force will increase. Proportionally, the tension will change. Even the spring will also get elongated. So kx naught plus x. So the resultant force when the block is, so here we'll indicate this h. Some other color, let me take it. Some h length is immersed here. So what is the, now for equilibrium, kx naught minus t naught equal to 0. Then FB naught plus T naught minus mg equal to 0. What is FB naught? Is equal to density of liquid, rho L will write it, density of liquid rho L Ag into H. Now when the block is, this at equilibrium. Now in the end, I'll ask you some very good questions. Okay, this we can, of course, we can get the time period. Just will analyze further some basic ideas of the various types of forces here. Now when block M is slightly depressed and released, find, okay, now we have to you have to find out the time period of oscillation. Slightly depressed by a distance x. Everything I'm putting here and released here. So then what is the net acceleration? So it will be, this will start accelerating up. Then this will also accelerate because they're connected by common string. So both will have same acceleration. So then the resulting equation will be kx naught plus x minus t naught equal to me. Then the new buoyant force FB minus t minus mg equal to me. So what is the new buoyant force will be rho L Ag H plus x. I think we can eliminate with the initial things all. So this will become kx, if I add up, kx plus rho Ag x.
It is FB plus T, no, sir.
FB plus T. Oh, okay, yeah. Thank you for correction. This should be called small m plus capital M into E. So this will become rho L. It is rho L. Rho L Ag small m plus capital M into x. So this acceleration will be opposite to displacement. It will get confused. That's why I'm avoiding that negative sign. So how is this acceleration will be directed opposite to acceleration? So therefore, this will be example of SHM. So therefore, omega equal to k plus rho L Ag by small m plus capital M. Now look at the buoyant force. Is it a conservative force? Yes, it is. Spring force is a conservative force. What about the work done by tension? Net work done by tension is 0 here. That's why we can also solve by conservation of mechanical energy here. How the questions can be asked here is, rather than asking time period, more than one options. If the density of liquid is increased, then the time period of oscillations. I think you can take care here. able to get this. If the area of cross section of the block immersed increases, the time period decreases. You see all the parameters are there. Spring constant increases. Then if this is doubled, this is halved. I'll make it this 2 times. This I'll reduce by off. Then what happened time period? So more than one options instead of asking time period, because time period means everyone knows. They'll ask you about these queries. You have to what you should do. You should come back here. And you have to fight with this equation. Through this equation, you can analyze very easily. So bind force is a conservative force. So now when the block is oscillating, regarding the nature of work done by the bind force, we'll see that it is at equilibrium. When I depress it and release, it does positive work. Then when the conservative force does positive work, then potential should decrease. What potential will decrease? The potential of the liquid will decrease. Gravitational potential of liquid will decrease. So how the work done by bind force and gravitational potential of liquid are, they're opposite. If bind force does positive work, potential of the liquid decreases. Gravitational potential. If the bind force does negative work, gravitational potential increases. I think so many things are there, no? Here. So many queries can be asked when FB does positive work, gravity potential in G decreases. When FB does, bind force does negative work, gravity potential in G increases. Net work done by tension here. In fact, it will be 0 here. Please do analyze. These are very important. Studying like this is something very important. Don't end up just with answer. What's going on? What all happening here? SHM is the best topic again to revise all of your mechanics. I'm making clear all of